Alrighty, so it's been a while since I've actually done some exorcism exercises. February was functional February, and I guess Clojure would be classified as a functional programming language. So I got through how many exercises? 26 out of 84 exercises, about a third of the way I think it was. Um, and it's been pretty good so far, but I just haven't kept up with it. So I'd like to. That was supposed to be January's language for 12 and 23. Let's see if we can go to the exorcism website to talk about, or see where the 12 and 23 is. Okay, so month number 2 of 12 and 23 is functional February, and they had some different little videos that they had about that. And there's this thing about learn and earn the badge, earn the functional February badge for completing and posting 5 exercises in one of the following languages. So I don't know if I get the badge of Clojure, because I don't think so, because I already did 5 exercises for the month of January. But OCaml was on this list, and that's one of the languages on my list of things that I want to learn. Haskell's on my list as well, and F#. And Elixir, I already use Elixir in my day job, so I'm not gonna relearn that language. I know it pretty well. I would say I'm intermediate to advanced Elixir user, so it's not worth my time doing exercises for that. But OCaml is something that I've already started playing with it at one point, and so I'm gonna try and pick that up again. And recently, in the time between me picking up OCaml and today, OCaml 5 was released. From version 4 up to 5, so it's a big release. I think the main thing that came with the release was something to do with multiprocessing. So not entirely sure how that plays out, but we're going to try and pick up OCaml. Looks like I've already done the Hello World at one point, which is apparently 2.3%, so it may not be that hard to finish this entire. There's only 42 exercises. Okay, so let's first actually get the development environment set up. So the thing we need to install is OPAM. I may already have it, so let's check to see if I have that. I do. Very cool. So let's do. I got to update OCaml with OPAM. Let's see how we do that. Initializing OPAM on Unix. Oh, that's where I was. Okay, OPAM init, eval OPAM env. Let's see what OPAM init does here. No configuration file found using built-in defaults. Checking for available remotes, rsync, and local git. You won't be able to use Mercurial repositories unless you install. Okay. Error, missing dependencies. The following commands are required for OPAM to operate. BWrap. Sandboxing tool BWrap was not found. You should install bubble wrap. Okay. So let's figure out how to install that. Let me just make sure that I'm actually streaming. Looks like it. Okay. Record from here as well. Okay, the first command, OPAM, initialize the OPAM state. Stored in hidden folder OPAM in your home directory. It also creates a first switch, usually called default, although this is just convention. Switch is an independent OCaml environment with its own OCaml compiler. Okay, kind of like a virtual environment for Python, I suppose. I don't really know why I made that analogy, because I know nothing about Python. Second command, eval OPAM, and modifies a few environment variables to make a shell aware of the switch you are using. Okay, so now check the installation by running OPAM -- version. Is that different from what I just ran? It is. Okay. Oh, because -- version is actually the correct command, and it just gave me the help. Okay. No, that's not true. Yeah, I guess so. Version, but that's the version of OPAM, not the version of OCaml. OCaml is not there. Okay. Well, the init didn't work. Let me just make sure that that's taken care of. Why does OCaml require brep? What is the switch? Okay. How can I install that thing? We use brep to prevent. Okay, see the bubble wrap package for details. Let me make sure that figure out how to uninstall this. Installation, Meson Auto Tools. Bubble wrap. Okay, let's search for Ubuntu install bubble wrap. I'm not great at using the command line to search for packages. This one also had something specific to OCaml. I'm curious about that. Let's see. Getting this error. Okay, that's the exact one that I'm getting. Disable sandboxing update. Oh, am I wrong? I'm confused. Okay, let's just give this a try. Sudo apt-get install bubble wrap. What is my password? Okay. Installing a bunch of stuff. Now let's try and do that OCaml init again. Okay, this made it further than the last time, so that's promising. It said that this could take some time. So while that's getting set up, let me check out the repository for exorcism. It's taking a while to load the terminal. I gotta remove some of my plugins for ZSH. So we'll go into exorcism. Oh, that didn't do what I wanted. I want to go into exorcism directory. Make sure that we're up to date. Okay. And we'll check out the first exercise. So what I'm going to do is I'm going to move over. I usually like to keep my terminal and code editor on my second desktop here, and then my references on the first desktop. So this one was in progress, it looks like. We'll continue on from there and copy that guy. Okay. Go back to the terminal here. Something wacky happened there. Okay, I'm having this issue again where it's like, okay. Let's ignore that. Okay. So it should have now downloaded the exercise. Let's check to see if it shows up in our closure. And OCaml, there it is. Okay. Oh, okay. I remember Dune. Okay. So let's see if this gives us any help about how to start this. I remember using Dune. Dune actually, ironically, uses a Lisp syntax. So coming from Clojure, this is a little friendly. Okay. This is the README for exercise OCaml track. Notes contributed by. There's not much about like how to. There's a help. Okay. Running the tests. A makefile is provided with a default target to compile a solution and run the test at the command line in your exercises directory type. Just make. Okay. So our first exercise. Oh, actually, that was within the sleep directory. I thought these files were in the OCaml directory, but all of this is under the leap directory here. I may want to modify my git ignore to ignore some of these stuff. This exercisem is being ignored already. I don't know if it does any build files. We'll find out. Okay, so here's the project, or the README. The README is the one that is the leap years, okay, that we have to calculate. Let's check to see how we're doing on the other OPAM side here. Do you want OPAM to modify ZSH? Sure, why not? Otherwise, every time you want to access your OPAM installation, you will need to run eval OPAM environment. In normal operation, OPAM only alters all files within .opam. However, to be best integrate with your system, some environment variables should be set. Okay. Installing new switch packages. Switch invariant OCaml greater than 4.05. Well, while that's getting set up, we can at least start looking at the code here. So we have leap.ml. And it says let leap year, taking an argument. Where it says fail with leap year is missing. Okay. So we got to implement a function that returns whether or not a given year is a leap year or not. So let's say, now I'm also have Vim mode here, and I'm not really proficient with Vim mode, so we're gonna give this a try. Might just end up going into insert mode most of the time. So we'll say let leap year of year equal, and let's see, we're gonna want to use pattern matching here. It was kind of nice, and it's nice having pattern matching. OCaml Clojure didn't have pattern matching, even though it was a functional language. Most Lisps don't really have pattern matching in them. Let's see if there's some extensions for .ml. OCaml platform, okay. That looks promising. Let's install that and see what it helps us out with. Official OCaml language extension. 5-star review with 10 reviews, 89,000 downloads. Okay. Okay. It's got some stuff for ReasonML too, which is neat. All right. That is installed and enabled. And let's see if that gives us some nicer, there we go, that's some nicer syntax highlighting. OCaml bytecode compiler OCaml C was not found in the current sandbox. Do you have OCaml installed in the current sandbox? Pick a particular package manager in sandbox, clicking select package manager and unable to read the current switch. Okay, so it looks like we need to default global switch. Okay, so our switch is still not set up. Let's make sure that that's set up correctly. Switch installation failed. Clean up. Yes. Initial switch creation failed. Use OCaml switch create compiler to get started. Okay, so let's go back to getting up and running. OCaml switch create. Let's list available first, because I'd like to see if we can use the most recent. Oops. Switch list available. Oh, you know what? I think what's going on with my keyboard here is I may have remapped a key. Let's see if that works. Whoa, that did not do what I wanted. Still not what I want. How do I get out of this? That's not right. Okay, I gotta figure out what's going on with the keyboard here. We do have a 5.1 even. Current trunk. It says variants though. We probably want this base compiler official release 5.0. Let's do that. So I think it was OPAM switch create. So we'll do that. OPAM switch create 5.0. I need to do the whole thing. Switch invariant OCaml base compiler 5.0. OCaml system 5.0. Very cool. Hopefully this works. Alright, so I'm not going to necessarily spend time rehashing because all these exercises are shared between the languages. So let's take a look at how leap year was done in Clojure. Pretty sure we have one in Clojure. Maybe not. Let's browse the repository here. Clojure. There's no leap. Okay. So maybe that's not one of them that was shared. I know I did it in like Haskell. Yeah, I'm pretty sure I did it in Haskell. So let's give that one a try. Tracks, go to Haskell. I guess I need to go to my dashboard. Oh, here it is. Haskell here, completed. Yeah, I did that leap year one. Okay. Okay. So yeah, I did a simple, I guess this is a pattern match. Used a where clause to define this thing called mult of. I think, I don't know if OCaml has a where clause. I think it has a let instead, similar to Clojure. So I think I can say, if I would just want to copy how that's done, I can do let mult. What is the conventions for OCaml? It looks like it's snake case. So we're going to try doing snake case. Say mult of, and back to here, mult of x is equal to mod year x is equal to, okay. Mult of x is equal to mod x, oh, year x equal to 0. I think it's like let in. So far, it's giving me the correct syntax highlighting, so let's see. Let's give it a little, is there like a help section? If you need help, go to the OCaml's tracks documentation, exercise and program carry on the forum, frequently asked questions. Okay. Oh, it's usually like a hints file or something like that. Let's give this a try and just say, actually, you know what? Let's try, go back here. Clean up, yes, let's clean up. Let's try running this switch thing with sudo OPAM command not found. What? Okay. It's okay without the sudo, but with a sudo it complains. That's weird. A failure in the middle of the build may be caused by build parallelism enabled by default. Please file a bug. You can try installing again, including jobs is equal to 1 to force a sequential build instead. Let's clean up. Alright, hopefully that gets resolved soon, because it'd be nice to get on to solving this problem here. So let's take a look at, let's do learn, learn, wow, this is really annoying. Learn. Okay, my entire keyboard is just not cooperating with me right now. Learn x in y minutes. Here it is, OCaml. Okay, let's do a quick overview. When you're at the top level loop, OCaml will print an inferred type after you enter expression. Let inc x is equal to x plus 1. Okay, I gotta end things with a double colon when we're in the REPL, it looks like. For source file, you can use OCaml ci path to file ml command to print all names and type signatures. Okay. Comments are parentheses with stars, asterisks, variable, and function declaration to use let. OCaml allows single quote characters and identifiers. Prime. Inc. Int. You can specify the types inside of there. You need a mark recursive function definition. As such, with a rec keyword, function application usually doesn't need parentheses. Okay. Unless the argument is an expression, makes sense. Every function must have at least one argument. Since some functions actually don't take arguments, there's a unit type for it. Got it. Calling a function with insufficient number of arguments does not cause an error. It produces a new function. Okay, so we have auto currying. Let print and return x, print and line string of int x, x. Okay. No procedures, everything's an expression. Definition can be changed with let in. Okay, there we go. So let in, let in. All right, so that's what we needed. Let rec is even is equal to function. Oh, okay, so this almost looks exactly like the Haskell, except for instead of a where, we use a let. Now, I think Haskell has a let as well. I'm not sure when we would use a let versus a where. But let's just say we kind of copy over the thing from Haskell. So we just do that and oops. What? We don't need that guy. Okay. We have this thing that I said otherwise. I think that's because we can put essentially whatever in there, because it'll match to anything. Let's see if that's true. And yeah, n. So it's just like whatever can go in there. Is otherwise good? I guess most people would. I kind of like using otherwise, but I guess probably the correct or better thing to do would just be make this a underscore. And I think I want to line up our equal signs like that. So it's saying if it's a multi of 400, then it's true. If it's a multi of 100, then it's false. But if it's a multi of 4, then it's true. Otherwise, it's false. Now, does order matter here? Oops, keyboard is bugging out again. You know what? I also realized I should turn on my keylogger. That would have been helpful. Okay. So does order matter here? Because if it's a multiple of 4, it would usually be a leap year, unless it's a multiple of 100. Unless it's a multiple of 400. No. So the order does matter, but this is the correct order. So the first thing we want to check to see is if it's 400, and then if it's 100, and then if it's 4. So I think I had a better iteration of Haskell that I liked better. This was iteration 3. No, I think that's probably the best one. Okay. Yeah, I was trying to see if I could stop repeating the year thing, and this is probably the best way of doing it, just like do a where clause in there. All right, so hopefully we can have an environment set up soon so that we can run this, but this is still not working out so well. Okay. The following actions failed. Build OCaml base compile. The following changes have been performed. Install base big array, base threads, base Unix, OCaml options, vanilla 1. Okay. Error while compiling OCaml. Context path output. Okay, that's a problem. No acceptable C compiler found in path. So let's see how to resolve that. It's probably just something as simple as install GCC or something. This one's for Python, but we'll see if it's relevant to the problem here. It's not in your path. It means that you don't have a GCC installer, or it's not in your path environment. Okay. Debian base, Red Hat base, build essential. Let's give that a try. See what this make file does. Default clean test, test Dune run test, clean Dune clean. Okay. So the Dune, nothings. Test.ml is right here. Open OUnit2, open leap, let AE express got test. Test context assert equal expression got printer string of bool. Tests year not divisible by 4 in common year, AE false. It's such a weird name of a function. I wonder why they use AE there. What is MLI? Okay, MLI is your type definition. So it takes an integer and returns a Boolean, which our function does. It takes an integer, returns a Boolean. Okay, so everything looks like it checks out here. Lang Dune 1.1 version 1.5. Dune run test base OUnit. Standard. Okay. All right, let's see where we are with our installation now. That doesn't look good. Failed to fetch security Ubuntu not found. Unable to fetch from archives. Maybe run apt-get. Update or try with fix missing. I don't think I've run an apt-get update in a while, so let's do that. Setting up. Nice. Okay. Hopefully it's added to the path. GCCV. That looks surprising. Or not surprising, but promising. That's the right word. Okay. Let's try again to install this, to create this switch. Alrighty, let's go back to, while we're waiting on this, functional February on exorcism. They had a couple talks with some creators of these languages. Not sure where to find them anymore. But the creator of Gleam, and I believe the creator of Elixir, they interviewed. Jose Valim, I don't remember the creator of Gleam. But what's really, both of them, ironically, are on the same, what's it called, virtual machine, which is called Beam. Not sure if that stands for anything. And Erlang as well. I mean, Erlang was the original language that ran on Beam. Elixir definitely is the most popular language that runs on Beam. But Gleam is really cool. It's an ML language, similar to F#, Haskell, OCaml. ML family, but also interrupts with Erlang and Elixir. And I believe has multiple compile targets. So not only does it compile to Beam, but it also compiles to JavaScript or WebAssembly, one of the two. And so the idea is that you could actually write your code in Gleam and end up interrupting with Elixir, but also write your front end in it. Which is kind of neat. It looks like it's actually moving further along than when I checked it out last. So this may actually be worth looking into for work. We use Elixir at work, and it works fine. But I do like static types languages, and in particular ML languages with their type system. So maybe we'll give that a try very soon. But for now, let's focus on one thing at a time, I suppose. Processing 18 out of 27. While we're waiting on that, let's go back to learn OCaml and wine minutes. We use the let in there. Alternatively, you can use let and in construct. Instead of doing let in, you can do let this and this. Anonymous functions use the following syntax. Funx. Okay. There's a little distinction between operators and functions. Every operator can be called as a function by just wrapping in parentheses. There's a number of built-in operators. One unusual feature is that OCaml doesn't refrain from any implicit conversions between integers and floats. Doesn't just refrain from any implicit conversions between integers and floats. It also uses different operators for floats. So integer uses a plus, floats do a plus dot. Same thing with division. We're using the mod. Oh, interesting. Okay, so it's 5 mod 2. Am I doing that in our code here? No, I'm not. Of course I could. Well, interesting. I wonder if it matters. Can I do mod 5.2 or 5 mod 2? Here we want year. Let's see. GW I mod escape. Right. Okay. So that looks like what it's supposed to be. But I'd love to experiment to see if that actually matters or not. Unary minus is a notable exception. It's polymorphic. Okay, so it doesn't matter. Integer only. However, it also has pure integer and float forms. Okay, so if you want to make it pure, you put a tilde in front of it. You can define your own operators or refine existing ones, unlike SML or Haskell. Only selected symbols can be used for operator names, and first symbol defines associativity and precedence rules. Okay. More useful a reciprocal operator for floats. Cool. Lists are enclosed in square brackets. Items are separated by semicolons. Wow, that's interesting. Tuples are optionally enclosed in parentheses. Items are separated by commas. Okay. Correlate, if you try to separate list items by commas, you get a list with a tuple inside. Probably not what you want. Okay, So that's why they have to be separated by semicolons, because of this optional parentheses around tuples. You can access individual list items with a list nth function. There are higher order functions for lists as map and filter. Data last, so you do your function first, data last, as you would with most curried languages. You can add an item to the beginning of a list with the cons constructor. Arrays are enclosed in... Okay, so there's a difference between a list and an array. Array requires this extra pipe, horizontal bar. You can access array items like .0 instead of the nth. So similar to a bunch of languages have distinction between lists and arrays. Strings and characters use double quotes for string literals, use single quotes for character literals. Single and double quotes are not interchangeable. This will give you a single character string, not a character. Strings can be concatenated with the caret operator. Strings are not arrays of characters. You can't make characters in strings and expressions. You can convert a character to a string. String.make one mychar. There are more convenient functions for this purpose in additional libraries, such as core.standard, that may be installed and or loaded by default. There's a printf function with format strings. Unformatted read and write functions are there too. I don't know if there's a string interpolation or not. You can define types with a type, some type construct. More interesting types include so-called type constructors. Constructors must start with a capital letter. Okay. ML type. Type constructors don't need to be empty. Okay, so if you have some type that has data associated with it, you say of, and then the type of the data that's in it. Can be used to implement polymorphic arithmetic. Okay. Point on the plane. Essentially a typed constrained tuple. Okay, so if you're going to define more than one, it has to be separated with asterisks. So essentially indicating very, very distinctly that this is a product type. And of course, if you have the bar, then that's a sum type. Types can be parameterized like this: type in lists of anything. A can be substituted with any type. Okay, so does that have to be a single quote, or can that be... Yeah, I guess so. Okay, so in other languages, usually they'd use something like a capital letter or something like that. Types can be recursive, like in this type and list 2 built-in list of integers. Okay. Matching exact values. Okay, so they're doing this match with. Alternatively, you can use a function keyword. Okay, so that kind of answers the question about how to do that. We're supposed to have this function keyword instead. Here's a question. Is that before or after the let in? I believe it's before. You can use a function keyword. Matching predicates, aka guarded pattern matching with a when. Matching type constructors. Okay. Built-in syntax for cons obscure the structure a bit, so we'll make our own for demonstration. Okay. All right. That was a quick overview. This is still trying to... So it looks like we're actually like compiling OCaml's compiler from source, which is hopefully not going to take too long. In the meantime, something we can do. Nice. Welcome to OCaml 4.13. Use the editor pane and press Ctrl-E. Or type your OCaml phrase in the box and press enter. Use Shift Enter to break lines without triggering execution. Use Control plus or up once to reuse a previous entry. Use Control up, Control down to navigate through history. Use editor pane, press Control E. Where's the editor pane? Here it is. Okay. All right, let's actually try our code here then while we're waiting for environments to get set up. Whoa. Okay, I'm not good at, let's try going to visual mode, selecting everything, yanking it. Hopefully that puts it in the right. Nope, still didn't. So it didn't put it in the same buffer or the same clipboard. So how do I want to copy this? Let me just disable the Vim plugin for now. Keyboard's bugging out again. Okay, thinks that I have like a sticky alt key essentially. Extensions, nope. Control Shift P. Extensions, install extensions, there we go. Okay, let's turn off Vim mode for now. Disable reload required. Eventually I'll get better at using Vim, but for now I got too many things I'm learning at the same time. So we'll not do that for now. Okay, this is still not looking great. Processing 18 out of 27 tasks. No, I could also just do this directly in Exorcism. But the whole idea is to get an idea of things, eval code. Syntax error. Okay, so I can't do this let here. What can I do then? In. Let's instead of this. Okay, maybe what I need to do is I need to do let mult of x here mod. Let me take a look at this again. Let in let x equal 10 in let y equal 20 in x plus y. So let's go back to the editor. Let mult of x. I need this to be inside of the, because I could do this where I could say let mult of x equal year mod x in, and then do the let leap year equal function, but I oh, okay. Let's go back to the other thing here. The thing where we talked about the function versus a mad. Okay, so this would say match x with, and this one being the same as that. But if this will take whatever argument we pass to it, and then match it with that. The question is, can I actually just call this? Okay, so if this is, let's go back to here. I just want to take the year and call multov on it. Okay. Multov year x. Let's just do this for now. So I believe what I can do is I can say let multov year x equals year mod x equals 0 in multov year, and just thread that year all along there. And then we can see if we can improve on that a bit. So let's try evaluating that. Syntax error again. Multov year 400. So what's going on with this? Syntax error right there. Function. Well, I think I can do when or where. When, right? Now this is really bad. I don't think I should be doing this at all, but we're going to give it a try anyway. Nope, that's not right either. Okay. Let me make sure that equals is what I... No. Okay. That would explain part of my problem there. I should not be using equals. I should be doing that guy. Okay. So let's see if it works with just the arrows now. Save. Okay. Oh, that's not what I wanted. Eval. Okay, still have the syntax error. Okay. So let's go back and add those whens back in. Because I believe essentially what this is saying is this is acting as pattern matching, but it's not really doing the cond bit. Oops. Okay, eval code. Syntax error doesn't like the what does it not like? It added those for me. It added the semicolons for me, but it's yelling at them. Am I not closing out something that I need to? True and false need to be lowercase, perhaps? That might be what it is. True, false, true, false, eval code. Nope, still doesn't like that. Well, let me just make this really distinct here and just say multov year x, and that just returns true or false. I don't really need the in. Okay. So leap year is now an integer that, a function that takes an integer. Not sure why it's also taking a second parameter though. Ah, because function will take that extra parameter. So if I were to call leap year of 4, it still needs another parameter. So if I were to do leap year of 4 unit, it gives true. Okay, so function here is essentially injecting another argument. What happens if I do that and now do, well, no, because I can't, I need to tell it where to put that argument. We'll try removing that, see what happens. Eval code. This expression has type int bool, but an expression of type bool was expected because it's in a when guard. Makes sense. Let's search for, essentially what we want is OCaml cond. We want like a cond sort of thing for OCaml. Okay. Nope. Let's give this a try. Let's ask ChatGPT, because it sometimes does a pretty good job. In the meantime, how's our compilation doing? Uh-oh. Okay. Okay. We did finish correctly. Hey! We got a switch. It only took a while. Check the installation was successful by running which OCaml. Which OCaml. Good. It's got 5. OCaml version. OCaml version. Lovely. Okay, we will learn about the OCaml top level and other install tools in the next section. Excellent. Pick another sandbox. Let's change that setting again. 5. There we go. So hopefully it does a little better job now there. Okay. So now that we have that installed, what are some things that we can do with the OCaml tooling? I love it. What I loved about the closure tooling is that I could just simply, there we go, select a sandbox. Open a sandbox terminal, 5. Let's see what that does. Okay, not sure what that did. An error occurred starting the language server OCaml LSP. Let's see. Sandbox LSP is not installed in the current sandbox. Okay. Let's give that a try. OCaml LSP server. Installing OCaml LSP server. OPAM install OCaml LSP server. Let's do that. Okay. Well, that's going on. Let's ask ChatGPT. question here. Looks like the login didn't happen. Not sure why. Probably because it's like crashed or something. Look at that. It's down. Just going in circles here, looks like. Alright, that's not getting us anywhere. You know what? I do have now the Bing one. Let's see if it can help me with the problem. Write an OCaml program that returns whether a given year is a leap year or not. Okay, that is correct code, but I'm hoping we could do something a little bit more elegant. Let's actually see if that compiles correctly. Go over to our. So you know, at this point, I think we can actually use our setup here. So we'll say, whoops, that's not what we wanted. Copy this. Whoa, can you show me another way to write this program using pattern matching? That's awesome. It's neat that it knew that that was an option too, or something to suggest. Okay. Match year mod 4, year mod 100, year mod 400 with 0, 0. I don't like that. Okay. Can you pattern match on the numbers 4, 100, and 400 instead of the result of the mod function? Somehow lost the entire word pattern, but we'll see if it understands that or not. In the meantime, let's see how LSP server is doing. 32 out of 81 tasks. It seems to be moving along. All right. Okay, pattern matching in OCaml only works in values that are known at compile time, such as constants or constructors. Interesting. The numbers 4, 100, and 400 not values that can be matched against a variable like year. The mod function returns a value that is computed at runtime based on the input year. Therefore, you need to use a mod function to get a value that can be matched with different patterns. That did a pretty good job of explaining that, I think. Let's see, though, if it can... Let's see if we can get something a little bit better than this, though. Can you show me a version that is closer to the first version you gave me, but does avoids using nested if blocks? Okay. So this is similar to the first attempt that I had on Haskell. It's not wrong. It is nicer. Maybe I'm just this is a different language and having to get used to the tools of this language now. Okay. In the meantime, let's give this a try and say I'm going to go into the OCaml directory, into Leap, and I should just be able to run make and see what it does. Library OUnit not found. Okay. How do I now install the libraries that I need? It's probably another OPAM thing that I need to install. I'm getting an error from that says, how can I fix that? Whoa! OCaml LSP server is installed now. Looks like. Okay. Merge extension. Okay. Well, that's installed now. In the meantime, let's go back over here. Seems you're trying to use OUnit, a unit testing framework for OCaml. The error message indicates you're missing the library OUnit. You can just do OCaml unit, OPAM install OUnit. Okay, we'll do OPAM install OUnit. Seems to just be hanging there. Let me do it in here. OPAM install OUnit. So it looks like the switch also holds on to our dependencies for us here. Is there, let's see if there's something in our directory that indicates to OCaml what it needs to install. Dune project, Dune. Libraries, base and OUnit. Alias, name, build test, deps, env, dev, flag, standard, one error. Done. Let's try running make again. Library base not found. Let's try just doing an OCaml install in this directory and see if it pulls from Dune. Maybe Dune itself has. Is there a way to install the packages in the Dune file using OCaml? Install packages using OCaml by create a package.OCaml file in the same directory as Dune file, Dune generate a package install file. That's not what we want. Want to install the packages listed in the Dune file. Let's try just installing or searching in here Dune, install libraries. If you want to use OCaml to install packages built with Dune, you can either use OCaml pin with the URL of the package, browser open install with the name of the package. Dune will generate install files. You can also use Dune install directly. Dune install. Okay, that didn't complain, but didn't seem to do much either. Did that do stuff? I don't know. Nope. Okay, OCaml install base. We'll do that for now. build. All right, let's see what we got here. Initially, projects, install, building a hello world. What I'd like to do is install, let's see, libraries. Doing libraries, dealing with foreign libraries. Other common patterns to produce flags, upgrade full configurator. OCaml integration. Let's try Dune build. See what that does. Okay, it happened very quickly, but it did produce a build folder. Let's add that to git ignore. Let's do OCaml build. Okay, just to make sure that that doesn't get committed. And while we're at it, let's just try running make again, see what that does. Implementation leap ML does not match the interface leap CMI. The value of leap year is required but not provided. Okay, maybe the example code where did the file go? There it is. Okay. Give that a try again. Make Dune clean, Dune run test. Okay, it passed. All right, so I have things more or less set up. I know there's more stuff that I could do with Dune, but we're gonna try submitting this now from the command line. And close a bunch of these tabs here. Here we are, back to the leap guy. Iterations, SJ. There it is, which was provided to us by Microsoft Bing. And we're going to mark that as complete. And in the meantime, we're going to take a look at how other people solve this, because I'd like to see if there's a better way of doing it. Cool. Year when year mod 400 is equal to 0. Okay. So instead of doing this divides thing, so people are doing one over the other. They're doing a pattern match with a guard, but then putting it directly in there. Or they're doing defining a divides. Okay, so this is actually similar to what ChatGPT actually recommended for pattern matching there. Okay. Yeah, honestly, I'm not seeing much of a more elegant solution, to be honest. Um, I think I think something along this line is probably the best. So let me just revise this because, but I think you can still do a let mult of year, but we're not saving much, right? I guess so. So the question is, I remember there being an issue with us putting a function in here, year. Um, Year and num x equals year mod x equal to 0. So I think there was an issue with doing mult of y 400. So let's save that and see what happens. It's fine with it. Okay, so I like that better. Let's do that. I like to have the full thing typed out there, even though I have to repeat it here. So we'll do mult of year 100. Now this is not necessarily any more concise, but I don't know. I kind of like the fact that it kept the definition of what it meant to be a multiple separate. It's probably not a big deal. Still run. Nope, division by 0. Look at that. Because this shouldn't be 0, that should be 4. Great. Alright, we're going to call that a day. We've got OCaml 5 installed, Dune working, we got the VS Code stuff set up. We used, I used Bing Chat for the first time and it worked pretty well, gave me the answer that I'm looking for. We've got exercise finished in OCaml. If I complete 3 more, then I think I can get the badge for the functional February. A little painful, but we got there. So yeah, that's it for tonight.